when we start doing quantitative problems, we need to ask what the question is actually asking us. This question talks about a cup of coffee. It's cooling down from 75 to 20 degrees. What it's asking us is how much energy is being released to its surroundings. Now we need to look at our question and see what information it's giving us. Well, it's giving us a mass here of coffee. So we know that our M is equal to 140 grams. We also have a starting temperature and a final temperature. So that means that we've got a change of temperature. So that means we've got a delta T, which is equal to 75 degrees Celsius, and our final temperature, which is 20 degrees Celsius. So we have a change of temperature of 55 degrees. So this is the information that we've gotten from our question. Now, the question is asking for the energy. So energy being written as Q. Now we need to use our knowledge of thermodynamics to remember the equation of mc delta T, where m is our mass, c is our specific heat capacity, and delta T is our change in temperature. So C in this situation is for water, which is equal to 4.18 joules per gram degree Celsius. And this is the specific heat capacity of water. So now we have all the components to answer our equation. We have our mass, our change in temperature, and our heat capacity of water. So now we can just write this into our equation. We get mass of 140 grams times by our capacity of water, which is 4.18 joules per grams degrees Celsius. And we have our change of temperature, which is 55 degrees Celsius. Now notice that I've left our units in here, because what you should do when you write out your equation is find out that our grams will cancel with these grams and our temperature will cancel with this temperature. So that means that our final result, which we should be hoping for, is going to be in joules, which is our unit for energy. So that's exactly what we're after. So our energy is in joules. Now we can just plug our equation into the calculator and we get 32,186 joules. Our units on both sides work, and we end up with the correct answer. We could also write this as kilojoules, which I'll do below, which is Q is equal to 32.2 kilojoules, which is the same answer, we've just moved the decimal point. Now let's look at a second question. For this question, we're going to be looking at doing the same process for it. So our question, suppose a bag full of ice is at 0 degrees, sits on the counter and begins to melt to liquid water. How much energy must be absorbed by that ice if 2/3 of it is melted? We need to go and look at what the question is actually asking us. This time, again, it's the energy. It's asking us how much energy is absorbed to melt 2/3 of our ice. Well, how much is 2/3? Well, our original mass up here is 450 grams. So our mass is equal to 450 grams, but we're only melting 2/3 of it. So we can just times this by 2/3. Now we're again looking for the energy. So our energy in joules is going to be equal to MHF, where M again is our mass over here, and HF is a constant that comes from the energy required to melt ice, and that's 334 joules per gram. Now we can just put it all into our equation. We put in our mass, which is equal to 450 grams times by 2 over 3, and our constant HF, which is 334 joules per gram. At this point, we should do a units check. We have grams and a 1 over grams, so they cancel. And we're left with the joules, which is what our answer is wanting. So now we can plug it into our calculator, which comes out to be 100,200 joules, which, again, I'm just going to simplify and write as being 100 kilojoules. Finally, we're going to go through our last example, which is another quantitative problem. So this question says that suppose in the icy hot lab, the burner transfers 325 kilojoules of energy to 450 grams of liquid water at 20 degrees Celsius. How much of the mass of the water would be boiled away? So this question is asking us for the mass of water that's going to be boiled away. What we do know is the amount of energy that we've been supplied with the system. So how do we solve this one? We know that water boils at 100 degrees Celsius. So seeing that we've got a temperature at 20 degrees, we've got a temperature change to 100 degrees. So we know that we've got a delta T equal to 100 minus 20. So it gives us a temperature change of 80 degrees Celsius. We know that we have a mass of liquid, which is going to be 450 grams. So now we can calculate the amount of energy needed to raise 450 grams worth of water by 80 degrees. That comes from our Q is equal to mc delta T. Our mass is 450 grams times by our C of water, which is 4.18 joules per gram degrees Celsius, and our temperature, which is 80 degrees Celsius. Doing a quick unit check, we have Celsius and grams, we're left with joules is what we want. So we know that we're going to get an answer in joules. We can now plug it into our calculator, so we'll end up with 150,480 joules. But the energy that we've used here is less than the energy that we've put into the system. That means that this additional energy has been used to boil the water and turn it into a gas. So let's calculate how much energy that actually is. So I'm just going to write QV, this is the energy that's left to turn it into a gas, is equal to our starting energy, 325,000 joules. And we're going to get rid of the energy that we use to heat the water to 100 degrees. So 150,480 joules. Which, plugging this into a calculator, we get 174,520 joules. Now we can actually work on the part of the problem that's asking for. What is the mass of water that has been boiled away? Well, we know an equation, which is Q is equal to mHV, where HV is equal to the vaporization energy needed to turn water liquid into a gas, which is 2,260 joules per gram. Now, our equation here is not written as M, so if we rearrange this, it gives M is equal to Q divided by HV. And now we know our values for Q and our HV. We can put them straight in. So our Q is equal to 174,520 joules, and our HV is equal to 2260 joules per gram. Doing a quick unit check, we have joules over joules, so they can cancel. And our grams here is going to be 1 over 1 over grams, so that just is equal to grams, which is what we want because our mass is also going to be in grams. Now that we've checked our units, we can plug this straight into the calculator. So that gives us a value of 77.2 grams. And that there is the mass of water that has been boiled away.